Alright, we are live. That was a weird series of events. Alright. Had a lot of people not make it back. Did I share? I haven't shared. Alright, copy. Paste. Did I get my phone? Yeah, I did. Alright. We are... Still waiting to start. I'm going to send a couple messages real quick for those of you that are in here. Alright, it is just about time. I have a handful of people in the room. I'm going to give it just a moment longer. What this is to. Before we start, we are. Now I might get into some more stuff besides just this lesson. There are a number of transformer drawings, and I don't think those are in this. And that is important to know. Yeah, I didn't put any transformer pictures in here. So I need to, and I might, whenever we finish going over this quiz, I might put up the next quiz and then go live immediately with another live stream about transformer drawings, maybe is the word. So that is out there. Because if you look in your Transformers book, there should be a number of drawings. And I believe that is the important bit out of these lessons. Lessons 3. Yeah. Now you will need to uh, Yeah, it's going to be a bunch of drawings on the test. And you should have the test with you. So, uh, at this point. So that's good news? I don't know. It means I'll have to be careful and not, like, blatantly read off the test. Okay, let's get started. We got 15 questions to get through. If you have not made it back from going to get your test, I mean, you've still got 10 minutes to get your test. So we are watercolor. We are starting now. All right. Let's go and let's get started. The majority of three-phase transmission circuits in the United States are designed with only three-phase transformers connected together to obtain three-phase power. This is false, with page 71 as the reference. It should be single-phase transformers connected together. The way that this all works. Let's log on to the Blended Learning website, and I will cover some of that. So if you go outside and look at the transformer leading to your house, that is a single-phase transformer. If you go to a business, most businesses, media clip. Let's pull this up. Okay. If you go to a business, there are 3 separate transformers. If you look at a picture like this, each set of these little teeth looking thing, it's a coil. It's a schematic drawing of a coil. Each pair of these vertically is a transformer. So here's transformer 1, transformer 2, and transformer 3. They're connected together in a way that provides three-phase power. And depending on how you connect them together determines what type of power and voltage and all sorts of things you can get. Today, the majority of dwellings are wired with 3-wire service. So this is single-phase 3-wire service. In the secondary winding of a single-phase transformer, the neutral wire generally carries a current equal to that of either of the 2 outside wires. So the neutral wire carries the difference of the 2. It carries the unbalanced load in a single phase. Transformer. Excuse me. Transformer polarity refers to the voltage vector relationship of the transformer leads as brought outside of the transformer case. That is on page 73, so you should be able to know where we're at this point. We're pretty deep into the book. And that's transformer polarity is just that. It's the it's the definition. What that means is the voltages are a certain number of degrees out of phase with each other, and the transformer polarity will determine that. it's more complex than I can go into in just this little bit. And it's not as important to the grand scheme of things. Mostly that you know the definition and vaguely what it means, or what it references. The methods used to test for polarity and check transformer lead markings do not include. So in your book it will list a number of tests, and polarization index test is not one of those. So the AC test and the DC test involve putting that type of voltage on the transformer and seeing what you get out of the transformer. Transformer comparison is basically just, and this is on page 74, by the way, polarity test methods. Transformer comparison is just comparing it to something hey, I know what this one is, let me compare the two together. And I can't explain polarization index test because it's a bunch of words just put together. Doesn't actually exist. A blank is a three-phase connection method that has the wire from both ends of each coil connected end to end to form a closed loop. A delta connection. I will take a moment and draw this out. You can look at a picture of it on page 76 if my drawing does not do it justice. Oop, that's not what I wanted. There we go. Let's see if I have a curve. I don't have a curve. Looks like we're freehanding it. Wish me luck. Oh, I don't want red. I want black. Alright, so a delta wired transformer is drawn two different ways. It is drawn as a triangle. If you are at all familiar with the Greek alphabet, or paid attention in geography, you know a delta means triangle. So this would be transformer A, B, and C. Here is the lead. So what this is doing, you take one lead from transformer A and connect it together with transformer C. Then you take the other lead from A and connect it to B. Then you take the other leads from B and C and connect them together. That's drawn out in a more schematic way. Sorry, I'm having to focus while I draw. So we're getting a little bit of dead air. But this is a transformer. A delta transformer would be just drawn, so we have our A, B, and C. And there's a lead off of each of these. Let's So this would be a delta drawing in a different form. This is it drawn out one way, this is it drawn out another way. Let's label it. All right, then go back. In a balanced three-phase delta-connected system, the line current is equal to blank times the current in one of the coils. That will be 1.73. So there's a multiplier in three-phase. Things are in three-phase. Things are either going to be the same or times 1.73. That's the square root of 3 is where that number comes from. Three-phase, it's the square root of 3. I can't answer the phone right now. In delta, its current is times 1.73, and in Y, its voltage is times 1.73. We haven't gotten to Y, but that's the two of them, delta and Y. In delta, it's current. In Y, it is voltage. So a Y connection is a three-phase connection. I'm going to open up a new. Let's save this old one. This one. Man, I have something labeled for this. Oh well. I'll find it later. Alright. So, in a Y connection, so delta, you draw a triangle. In a Y connection, you draw a Y. And then, so we have A, B, and C. In a Y connection, one end of each coil is connected together, and then you connect the other ones to your line. So this would be like L1, L2, and L3. So, drawing that the other way, yeah, I don't like that at all. I don't like that either, but yeah, let's. So, in a Y transformer, you have these three connected to your lines, so L1, L2, and L3. And then the other legs are all connected together. So, real quick, I'm going to draw them right next to each other. This is Y, and this is delta. So we are going to have a lot of drawings to go over. And I might flip through the homework just so you don't have to deal with my drawings so much. You can deal with the professionals. Technically, I'm getting paid to do this. So you've got Wye and Delta. If you look, you can pretty much see a difference in that in a Y transformer, one it's one leg is connected to each one, or one leg is connected to L1, L2, and L3, and the other three legs are all just tied together. Like you wire nut all of them just together. In a delta, they are one side, so A is connected to B and C, and B is connected to A and C. They're connected in a loop. So you can like start at one spot, go through A, go through B, go through C, and go back to A. So that's a difference. And that's what most of this Transformers test is going to be about, is identifying Y versus delta. More things about the Y. To identify them from the voltage, Y has weird voltage. So that's like 208, 277, those sorts of things. If you take the lower voltage of a dual voltage transformer and double it and it's not the higher voltage, Y. It's a Y transformer. Ooh. Let's undo. Yeah. So 122, 44, 80, that's a delta. Okay, I think that covers it. Now, if they are drawn upside down, then they're just drawn upside down. I will draw those again for you, but we are on like question 8. Oh, we're on question 8. We're doing good. Oh, it's 205. We're not doing as good as I thought. A Y system is also known as a star system. A Y to delta connection may be made with 3 single-phase transformers. Yes, that's how it's normally done. In a Y to delta connection of 3 single-phase transformers, one unit may be disconnected. So, yes, you can disconnect one unit and make an open delta. Basically this. I'm not going to erase anything. But you can basically do this. And you still get all your connections. Everything works, just you don't have the capacity you used to. So you're only operating at 57% capacity. That is an advantage to a 3-phase system, though, because you can take some of it out of service and still have it running. The 3-phase bank of single-phase transformers connected delta-delta. Yes. That's what we just covered. A open delta, so that's this, a V connection. Like I've said this a handful of times, electricians are very creative with their naming schemes. All phases of a three-phase transformer have the same relative polarity. That is true. All phases will. And then, why do delta connected transformers with properly marked leads always have an angular phase displacement of... So this is in the book. This isn't something I would try to memorize. I would just look up, and that is on page 94. Maybe highlight it, because this will be open book. So, starting at page 92, it gives you all the different types of connections with drawings, and it tells you the phase displacement of those types of connections. Yeah, okay. So that finishes this. I'm going to, let's check. Okay. I'm going to launch the next one, and I'm going to stop this this stream, but I will pick up a new stream immediately, and I'm going to go through a bunch of more transformer drawings. What's the next lesson named? I didn't do a good job naming my stuff. Harmonics. All right. Oh, short quiz. Okay. So I will be right back with a new stream, so stay tuned. I just want to change. I want to cut the video so that it's more concise.